Okay, let's start the short answer question with number 16. So this question, the limit right here, is about the asymptote at plus or minus infinity, right? And you know there are three cases, so I invite you to revise the three cases, and it depends of the degree of the top and the bottom. Okay, in the first case, like that, when the degree of the bottom is smaller than the degree of the top, the limit is simple. The limit is 0. Okay, that means that the asymptote at plus or minus infinity is y equals 0. That's what it means. Okay, everything is disappearing here. Okay, when they have the same coefficient, the same degree, sorry, it's not a coefficient, it's degree. When they have the same degree, for example 3 and 3, you would be doing -6/3. You do the ratio of the leading coefficient, that would be -2. That means the asymptote would be y equals -2 and the limit is -2. When the top is higher, you have to do the long division. I think there's a question like that somewhere in the... Oh yeah, well, right here. Okay, alright, so here's another end behavior question. End behavior means at plus or minus infinity, right? That's what it means, end behavior. So in this case, the degree of the top is higher than the degree of the bottom. So to find the equation, it's not y equals 0, it's not y equals the ratio of the leading coefficient. I have to do the long division. But here, actually, I'm kind of lucky. It's x plus 1 divided by x squared minus 5x plus 7. Okay, this is really getting frustrating. Everything is disappearing. But I don't have to do that, right? I don't have to do the long division here, because when I divide by a degree 1 like that, I can do a synthetic, right? So let's quickly do the synthetic. So if I divide by x plus 1, I'm going to put -1 right here. This is 1, -5, and 7, right? The coefficient of the divisor. No, dividend, sorry. And then let's do it. So 1, I bring down the 1, and I multiply by -1, so 1 times -1 is -1. -1 minus 5 is -6. I don't need to finish it, right? Here are the coefficient of my quotient, and so the equation is y equals, so it is equal to x minus 6. Okay, and if you graph this function x minus 6, you will see that it's very close to this function when x approaches plus or minus infinity. Okay, alright, so what do we want here? We want a rational function, so here we go, let's write it. Y equals, alright, rational function means ratio of two polynomials. The 0 are -1 and 2. So if -1 is a 0, that means x plus 1 is a factor. 2, that means x minus 2 is a factor. The vertical asymptote is x equals 0 and x equals 1. Okay, that means x minus 0, I don't have to write this is minus 0. X and x minus 1 are factors, okay? So I take care of my vertical asymptotes here. Horizontal asymptote, 1/2. Alright, so let's think a little bit. And no hole. No hole means I don't have any common factor, like for example, x plus 3, x plus 3. Right here, you would have a hole at 3, right? But we don't have that, okay, because there's no hole. Alright. So how do we handle this asymptote? Well, this is the horizontal asymptote. It's the asymptote at plus or minus infinity. If you are to expand the top, what do you have? I don't really have to fully... Oh gosh, everything is gone. I don't have to really fully expand it, but at the top I have an x squared, and at the bottom I also have an x squared. If I want my asymptote to be 1/2, at the top, I must have a coefficient of 1 and 2, or 2 and 4, or 3 and 6, okay? So here, how about we play with 3 and 6? Okay, so 3 and 6. That's going to be 1/2, right? I mean, come on, it's really complicated. You should put 1 and 2. But basically, let me not be ridiculous like that. let's just put it to whether here. Let's expand the top. Let's finish the problem completely. So we have x squared minus x, and then minus 2. Okay. And at the bottom, I would have my 2 right here. So it is 2x squared minus 2x. Okay. And that's it. This is how we get the rational function with the given characteristic. So y equals fraction bar. So x squared minus x minus 2 divided by 2x squared minus 2x. Okay, next one. It's nothing left here, everything is here, yeah. Next one. So what do I want here? F is a one-to-one function and the point negative 2, 5 is on the graph of f. Evaluate. Alright, let's understand that. So what does that mean that f of negative 2, 5 is on the graph of f? It means that f of negative 2, okay, it means that f brings negative 2 to 5, right? F carries negative 2 to 5, right? That's what f does. So representing it like that or like that, it's the same thing. So what's f inverse of 5? Well, if f does that, f inverse undoes what f does, right? This right here is f inverse. So f inverse of 5 is, well, back to 2, right? F inverse of 5 is negative 2, sorry. It's negative 2. And then what do we do right here? Well, careful, this is not the same kind of negative sign. Right here, we take the reciprocal. So what's the reciprocal of negative 2? It's negative 1/2. Okay? So, here it's negative 1/2. Okay. Write as a single logarithm. Okay, here, let me show you where everything is. You see? Oh, this is so crappy. It's not just my computer. Apparently, they all do that. Come on, Lenovo, fix it. Drives everybody crazy. Okay, alright. What do we have? Where am I? I'm right here. Okay. Write as a single logarithm. Okay. Well, the middle term is pretty simple. The middle term, so we'll take care of the other one after, okay? The middle term is ln of x cubed, right? You know when you have something in the front right here, you bring it there. What do we do with that? Well, actually, this is no different than this right here, almost, right? Why? Let me rewrite it. Here, I can rewrite it like that. Dividing by 2 is the same as multiplying by 1/2. Dividing by 2 is the same as multiplying by 1/2. So here we go. Right? Okay. And that's going to go inside right here. So right here, I still need to take care of my negative 2. We have ln of x cubed. And then we have minus ln of y to the 1/2. So y to the 1/2, which I probably will use a, this is so, I probably will use a radical notation, okay? And then we have a minus, okay, so we'll see that. Now, negative 2, what do we do here? Well, negative 2 is the same as negative, so how do you write 2? 2 is the same as ln of e squared. I'll leave the negative sign out. I didn't have to, but I'll show you why. Okay, so this is ln of e squared. Okay, so that's it. So now, so let me rewrite it here, ln of e squared. So now let me put everything under 1 ln, big fraction. Everything with a negative sign in the front goes at the bottom, everything with a plus sign goes at the top. So what do you have? You have e squared at the bottom, square root of y at the bottom, and x cubed at the top. That's it. That's what it is, right? So ln of e square root of y times x cubed. Okay? Good. Any question? No question. Okay, let's move on. Oh, here's an equation to solve, and you see the variable? Oh, it's the base of the log. I don't know if we saw an equation like that before, but hey, I mean, we don't need to have seen this equation for you to be able to solve it. Okay, well, you remember what to do. If you are stuck on a log or stuck on an exponential, write the other form. So what am I talking about? I'm talking about this formula that I've stressed a lot. Here, I'll write it using some notation. So here's a triangle. It's going to be the base of my exponential. Here's a circle. If this is equal to that, okay, then this is the same thing as what? That's the input, that's the output. So I'm taking the log. What's the base of the log? The same as this base right here. The base of the exponential. Now the output becomes the input, and the input becomes the output. Smaller. Okay, so that's what I'm gonna do right here, right? So here we go. So x to the 1/2, x to the 1/2 equals 4. And as soon as I write that, I'm like, oh well, this is an old equation. I know what to do. You know what x to the 1/2 means, right? It means the square root of x, right? So square root of x equals 4. How do you solve that? Well, that's not complicated. You just square both sides. So x is 16. We will normally have to check it for extraneous, but this solution will work. X is 16. Okay. The inverse function of y equals log base a of x. Well, that's there's no work to do right here. That's easy. Either you know it or you don't, and I hope you do know it because it's one of the most important things we've learned about logs. A log is the inverse of an exponential of the same base as a log. Okay, that's a definition of a log. I mean, for us, not the most general definition, but for us it is. The graph of the function y equals g of x is obtained from the graph of y equals 3. Okay, here, let's keep track of that stuff. Y equals 3 to the x by, alright, by what? Reflection across the y-axis. That means y-axis, that means x becomes negative x. Here we go. That's the reflection across the y-axis. So I'm going to call this one 1. A translation, 3 units to the left. I'm going to call this one 2. So translation 3 units to the left, you know what to do, right? Equals 3 to the negative x plus 3. Normally we would have started with the translation, but it's okay right here. A vertical compression by a factor of 2. Alright, so this is going to be the third one. Vertical compression by a factor of 2. So it's vertical and it's a compression, so I need to divide the y's. And here's by a factor of 2 plus 3. And a shift downward, so that's the last one, by 1 unit. Okay, well that's easy, right? So that's 3. A shift downward by 1 unit. You take everything and you subtract 1. 1/2, 3, negative. I guess I should have written it directly. Plus 3 minus 1. So g of x, they call it g. I use they as if I didn't write that myself. 1/2, or maybe I speak about me at the third person, singular or plural. I tend to think of him like that. Okay, alright, that's good. Right, I think. Reflection across the y-axis, translation 3 units to the left, vertical compression by a factor of 2 and 1 unit down. Oh yeah, I think it's good. Alright, how many more right here? Oh, look at all the marks. Let's clean up a little bit here. This is what happened when you use Word and this stylus on this Lenovo. It does it on every computer, it's a very big frustration. Oh, it drives me crazy. Okay. Alright. So, negative 61 pi over 5, which quadrant? Well, we need to figure out the coterminal angle, right? So negative 61 pi divided by 5. So I'm gonna have to add, right? And some 2 pi. So 2 pi, you call it 10 pi over 5, right? In pi over 5, 2 pi is 10 pi over 5. And how many right here? Well, 7 will do, right? 70 minus 61 will be positive, which is what we want. So 70 minus 61 is 9. So it's 9 pi over 5. And 9 pi over 5, I know where it is. You have to think of the unit circle when it's graduating in terms of pi over 5, right? So this is 0. This is a right angle is 2.5 pi over 5, right? 2.5 over 5 is pi over 2. Straight angle is 5 pi over 5. 3 right angles, well, 5 and 2.5, 7.5. So you see we're still below 9 right here. And then this is 10 pi over 5. And so 9 is somewhere here in the 4th quadrant. Okay, let me keep that. 9 pi over 5. And so the answer is Q4. Okay. Express tangent as the tangent of an acute angle. Acute angle, there's only one, and that's going to be the reference angle. Okay. So I need to figure out the reference angle. So before I do that, I have no choice. I have to go through the coterminal angle. So first coterminal and then reference angle. So when you write the coterminal, okay, so here, let me write you, this is 10 alpha is going to be the same as the 10 of alpha coterminal. And then when we're going to go to the third one, to the other angle, it's going to be plus or minus 10 of alpha ref. And this is going to be the acute angle right here. Okay, this is always acute. You're going to have to decide which one it is, if it's a plus or minus. It's going to be up to you to decide that. How? Well, you're going to have to look at where this angle is. It's a coterminal, so we'll be able to understand what quadrant it's in, and then figure out if 10 is positive or negative in that quadrant. Okay, so let's start. So the 10 of negative 1049 degree. Well, let's add some 360 here. So I'm gonna start with 3, which should do it, because 3 times 3 is 900. Yeah, that should do it actually. So let me see, 1049 negative, and then plus 360 times 3. Yeah, oh wow, something special happens actually right here. I'm done, basically. I don't have to go to the last formula because the coterminal angle in this case is equal to the reference angle. So that's it. So the time is 10:31. Okay. All right. Probably we need a little bit more space for this one. Where's my... this. Right here. And then tack. Yeah, that should do it. Okay. We've done plenty problems like that. We know what to do. I need to find the x and the y. Well, what are they giving me right here? They're giving me y and x, right? I just don't know if they're giving me this, if they're giving me this, or if they're giving me this. I'm not sure which one. Where does the negative sign goes? Because I know the top is y for sure, and the bottom is x. Okay, 10 is y over x, but I don't know how it goes. I can get r though. It doesn't matter if I cannot get this one. I can still get r, because it doesn't matter where you put the minus. You're gonna square it, right? So 2 squared plus 3 squared. So 9 and 4, 13. So that's r. And I know that actually the cosecant right here, the cosecant of x, is going to be r over y. So here we go. It's going to be root 13. And then here, I'm not sure if it's going to be over 2 or over negative 2. So let's answer that question. How do we answer it? Well, just like that. Secant is positive. That means what? Secant is r over x. R is always positive, right? That means x is positive. Okay, so it's not this one, it's this one right here. So you have y equals -2, x equals 3, r equals square root of 13, and with that you can write anything you want. And so cosecant is over -2, so here we go, we got negative sign right here. So it is negative square root of 13. Oh, yeah. It does that because there is a cell. You can see it, but there is a cell there. Okay, so how can I do that? How can I trick it? Square root of 13 divided by, not bad, huh? -2. Yeah, all right, that will do, that will do. I hear some of you applauding here. Well, thank you very much, thank you very much. Okay, all right. What's that? So that's a point on the unit circle and on the terminal side of the angle alpha in standard position. Okay, so I mean I don't really have to draw it, right? But basically, see what's going on here. I need more space, I guess. Right here. Let me take this. Let's go right here and tuck. Right here, yeah, that will do. So this is what's going on right here. You have the unit circle right here. Oh, this is pretty bad. You have the unit circle and the point on the terminal side of the unit circle and the angle. So I don't know where it is here, right here. I'll put it right there. Here we go. Right here. And here's the angle alpha. And this is alpha, and I'm gonna call this u and v right here, u and v, okay? And this is c1. Express the secant of alpha in terms of a and b. Well, that's very simple. Because I'm on c1, what's the cosine of alpha? Well, it's the x coordinate, it's u. What's the sine? It's v. What's a secant? It's just 1 over u, and the cosecant is 1 over v. Okay, the tangent is v over u and the cotangent is u over v. So basically it's the secant is 1 over the x coordinate. So it's going to be b over a plus 1. That's it. Okay. 28. Reference angle of 3.5 radian. Okay, that's not a difficult one. We know what the reference angle is supposed to be, the angle between the terminal side of the angle and the x-axis, the acute angle. The question is, where's 3.5 radian, right? Well, okay, so you need to be able to turn in radian. This is 3.14. So half of it, I'm just going to say, I'm going to round it to 1.5. And then this one would be 4.64 right here. And then this is 6.28 or 0 actually. Okay, it's also 0. So where's this triangle 3.5? Well, it's going to be right here, right? This is where 3.5 radian is, 3.5. So where's the reference angle? It's right there. That's the reference angle. Okay. So how do you find it? Well, you take 3.5 and you remove this right here. You remove the straight angle, right? So it is 3.5 minus pi. That's it. Simple. Almost there. Okay, these two questions, we've done them in class. Maximum and minimum value, so you know what you're doing, right? This is a vertical shift. When you're dealing with this function, a times sine of bx plus c plus d, this is the max, is always the vertical shift plus what we call the amplitude. Don't put a negative sign here, like it's negative, but a is 3, okay? I mean, the negative sign is just a reflection, okay? So the middle line plus the amplitude, and the minimum is the middle line minus the amplitude, right? So here it would be -5 plus 3, and here -5 minus 3. So max -2. Don't forget to tell me if you're writing the max or the mean, right? And the mean is and the mean is -8. Okay. All right. Phase shift, I think I've also asked in class for the period. So we call that TT is a period, okay? So here, let's take a little bit more space here. This is actually very formulaic. Very important when you graph, right? You know that I showed you. So let's take the phase shift. So that's pretty simple. Phase shift. You take everything inside the. You remember this is a sign. It doesn't matter if it's sine or cosine. It's the same actually. You take everything inside, and you equate it to 0, and then you solve for x, and that value of x will give you the phase shift. So what do we have? We have pi over 2x equals -3 pi over 4, and here I'm going to multiply both sides by 2 over pi by 2 over pi. So of course here there's nothing left, it's 1, and here this is gone, this is a 2, this is a 1, -3/2. Phase shift, -3/2. Phase shift. Okay, this is okay. I'll show you something else. It is so terribly frustrating. I'm gonna take white color and I'm gonna do a lot of bars. Look, I'm gonna fill that with bars. Oh, shoot, it should be white. See, it's not gonna go down. You'll see. Okay, white colors. It's gonna stabilize my cell. I don't know why. Don't ask me why it stabilizes a cell, but it does. Okay, I'm writing a lot of white bar, many. I should stabilize the cell actually. Okay, let's see if it worked. Usually it does work. So what I'm saying is the phase shift is, let's see, look, it should stay right here. Yeah, phase shift is -3/2. And let's get the period, and the period is, so for the period you know what to do, right? T is 2 pi. 2 pi is a regular period of sine and cosine, we've seen that, divided by the coefficient right here. This is just result from graph shifting, okay? So it's 2 pi over 1 times 2 over pi is just 4. Okay, so the period is 4. All right. Penultimate question. No, this is the ultimate. Right, that was 30 and that's the extra. Z varies inversely with the square of y and directly with the logarithm base 2 of x. Okay, let's try that. So Z varies inversely with, that means you gotta multiply it together, right? So inversely with the square of y. So it's not y, it's just square of y. And directly means you have to divide. That's what it means, okay? Check out the notes we did on that. You have to divide. Directly with what? The log base 2 of x. So this is a property. So here I'm going to write like 1, 1, 1. And if you take another set of value with z2, y2, and x2, you will have this, okay? Over log base 2 of x2. So they are telling me that z equals 4 when y is 3 and x is 16, so the log base 2 of 16, and they're asking me to find y when z is 12. I want to find y, and x is 8, log base 2 of 8. Okay, well, this is going to be pretty okay, I think. Let me take log base 2 of 16 right here. Log base 2 of 16 is a log base 2 of 2 to the power of 4, therefore it's 4. Log base 2 of 8 is log base 2 of 2 cubed, so it's 3. Okay, so we have 4 times 3 cubed. What is this? Okay. Actually, I'm going to go right here under So we have 4 times 3 squared divided by 4 equals 12 times y squared divided by 3. So these are gone. 12 over 3, well, that's just 4, right? So this is 4y squared. And so we have 9. So right here we have 9 equals 4y squared. So 9 over 4 equals y squared. So y is, oh, plus or minus. Ooh, I'm not sure I thought about this one, but I have to be logical. So y is plus or minus 3/2. Okay, done with the free response. That's the extra credit. Or extra question rather. Okay, done.